welcome back to Shannon's Lumber Industry Update. It's episode 52. And today I'm going to talk about engineered and modified woods. This is an episode that's a long time coming. I've been getting questions about various modified woods and engineered woods for some time and kind of wanted to compile them all together. So for those of you who've been asking, I appreciate your patience. Now's the time to talk about it. As always, thank you everybody for sending in questions and giving me just an endless amount of stuff to talk about on this show. And especially thank you to the folks who continue to support the show and gone over to patreon.com/lumberupdate and done a little sponsorship. Always appreciated, whether it's a monthly, annual thing. It's just very nice. Helps me keep the show going. And as I said, always very appreciated. So let's get a little bit into some quick industry news. It was interesting. We've talked a lot about lumber prices increasing due to the COVID pandemic and resulting supply chain and logistical issues. Done actually several episodes on this now and certainly updated it several times in this kind of industry update side of things. But what's interesting is we might be starting to see a glimmer of light at the end of the tunnel. Certainly, we saw the softwoods market go crazy first, and we expected to see the hardwood market follow, but would be some delay and for slightly different reasons. So we're hopeful that the reverse will happen and softwoods will start to correct, and then we'll see hardwoods correcting after that. Well, the lumber futures market has already corrected in some respect. And we saw a massive drop, about a 27% drop in one day, to the point where actually Wall Street limited the drop. I didn't actually know this was a thing. Apparently, since the Great Depression, there were several limiters put in place that prevented huge crashes that were resultant in the Great Depression. I don't know what I'm talking about when it comes to the stock market, but this is what I was reading in this article, and I'll post a link to it. But pretty big drop. And when you look at the growth, the massive spike in the lumber futures market, to see a slight correction could be light at the end of the tunnel. So I don't think we're going to see massive drops in lumber prices, in the next month or so, but we might start to see it certainly in the softwood and construction lumber market start to turn around as ideally, knock on wood, fingers crossed, we're coming out of the pandemic. At least that's what I'm hoping, and it does seem that we're kind of heading that direction. So it seems only logical that we'll see a slight rally. Or is it a negative rally when the price drops? Regardless, I'm hopeful that we will see some drop in lumber prices relatively soon. Keeping in mind, of course, that the hardwood prices, they're going to take a while to catch up when we start to see movement on the softwood side of things. Now, into kind of the new tech, and I saved this because I'm already, the episode focus is talking about modified and engineered woods. I had this article sent from a couple of folks, and it's about welding wood. And it's exactly that. If you take two boards and rub them together really fast, you create friction, which creates heat, and it gets to a point where you actually are welding them together. And it's kind of like two boards are now one board, and the cell structure and the lignin structure and everything in between is now one board instead of two. It's pretty fascinating. Certainly there are some limitations on the actual execution of the welded joint. In order to move the boards back and forth fast enough and on the appropriate frequency, you have to be able to hold them and move them back and forth at that frequency. But, very early days on this, call it experimental at this point, but talk about some cool joinery if you could actually weld two boards together. So as usual, I will include a link to this article. It's worth reading. It gets pretty technical and it's pretty fascinating to see where this could possibly take us. It's kind of LVL without the glue, just plain old welded together. Pretty fascinating stuff. So let's talk about modified versus engineered woods. And first, let's define that, if you will. Engineered woods, engineered hardwoods, softwoods, etc. The easiest way I think to describe this is it's a destructive process and then an additive process. So you have to have sawdust or wood flour or chips first. You have to have ground up wood, and then you're gluing it back together. You're forming it into particle board or to a lesser extent plywood. You're shaving off veneers, slicing off veneers, and then gluing them back together. Whereas modified wood is taking actual solid wood and doing things to it without destroying it. So you are injecting with resin, you are heat treating it to a certain level. You're taking that same board. If it's a 6-inch wide board by 8 feet long, you're coming out with a 6-ish inch wide board and 8-ish foot long board. It's still the same board. It's still the same species to a certain degree. You just modified what was already there. Whereas engineered, you're actually building something up from its elements, from its composite materials. MDF is an engineered product because you're taking wood flour and several other cellulose type products and you're gluing them together, you're assembling together to make that product. And it's important to make that distinction because it does change how we work with those products. It also changes how those products behave. Wood movement is kind of chief among those things. When you modify wood, you still have solid wood. So it's fair to expect some movement, or at least movement similar to what you would find in solid wood. Whereas, an engineered product, there's not enough wood structure left. You've ground it up into a wood flour and then glued it all together. So there really isn't that tangential and radial movement because there's no longer a tangential or radial plane. So it's important to recognize those things. Engineered woods, particle board, MDF, a lot of composite type materials like decking where you've got a plastic shell on a wood flour center, or some of the plastic lumber that is essentially wood flour and polymers that are all formed together. Those are engineered materials. So the converse of this, modified woods. What does that mean? Well, it's important to understand that there are a couple of different ways to modify wood, and those different methods kind of define the various and sundry brands of modified woods that you're going to find out on the open market. So, and you're going to find some of these modification processes, there may only be one player in the game. Many of them, there's 3-4 different players in the game. Some of them you may never heard of. Some of them you may go, oh, that's what that is. I've heard of that, but I didn't know what it was. So let's take kind of a look at the different ways to modify wood. You can thermally modify wood, and this is probably, I'm pretty sure this was the first guy in the game. This was the first method that came up. Thermally modified wood, well, we already kiln dry our wood, and we know when you kiln dry wood, it hardens the cell fibers. When you get it down to that low moisture content, below 10%, the lack of moisture and the temperature required to leach out that moisture, to evaporate out that moisture, hardens those cell walls. And we know that kiln-dried wood is harder than air-dried wood, and certainly harder than green wood. In many ways, it is more stable than air-dried wood or green wood because of those hardened cell walls slow down the absorption of moisture, but it also speeds up the release of moisture because they're not as soft and spongy. The cell walls, are not as soft and spongy. They're kind of harder, brittle, like a potato chip, if you will. So that's thermal modification. Well, somebody said, well, if some is good, more must be better. And probably torched and destroyed a whole bunch of wood. But thermal modification, torrefaction is another term for this. Baked, roasted wood are other terms that you're going to hear. This is where now you're increasing the temperature, but then you're sucking out the oxygen. In other words, you're eliminating, the key component for combustion. You raise the temperature too much and the wood's going to light on fire and you're going to have a great big giant bonfire. So you pull out the oxygen to prevent the combustion from happening and you start raising the temperature, and the amount of temperature raised will vary depending upon the product being created. Can be up to 300 degrees centigrade. And this is used when you're creating a lot of things like fuel pellets and such, true torrefaction, where you're creating charcoal. That removal of the oxygen and the increase of the temperature up to 300 degrees C is going to create those products for you. Thermally modified wood that's meant to be used as a building material, it doesn't quite go that high, but you will see temperatures 190 to 220 degrees C. Which, substantially higher than what you would be doing for your typical kiln-dried material. a lot of times there are a couple of different processes here, but a lot of times what's happening is then the wood is then cooled down by the injection of steam, and it's kind of slowly rehumidifying, if you will. But while it's baked to that incredibly high temperature, that low oxygen environment, you're getting a hardening of the cell walls. In some ways, you're actually chemically modifying the structure of the wood itself. And I've heard it compared to a crystalline lattice. It kind of reorganizes all those fibers and stitches them together into a lattice, making them incredibly strong. So the resulting product is you put in a softwood or a softer hardwood, and out comes a much harder softwood or a much harder hardwood. And you can't really call it a softwood or hardwood anymore at that point. It is a torrefied or baked modified wood. It's not the original species. The color is going to be changed. It's going to be a little bit darker, kind of like, a toasted marshmallow at that point. It has been roasted. The result of this is much harder, certainly. There is increased rot resistance because it's leached out a lot of all the water, and in many ways kind of waterproofed it, or made the fibers water resistant. The same process that goes on with Shishugibon, where you Shishugibon siding in order for it to be a good exterior barrier. You've baked it or burnished it to the point where it won't absorb water. Water can't get through because of that baked layer. So this is the real reason. We do this to make a more stable product and a rot-resistant product. Now, the downside would be it reduces its bending strength. It loses some of its structural properties because you've baked it and you've made it harder, and it can be a little bit more brittle because of that. But it's got nearly zero movement in most of the species that do this. And torrefied wood is usually a hardwood in product. You find this in cherry, you find it in maple, you'll find it in ash. They've experimented with some softwoods, and that will work, but the best products tend to be ash. Baked ash is probably the biggest one, and maple is another one that's pretty huge in the market. Now, the other thing is the resistance to fungus and things like that can be reduced because the extractives, the natural resins and things in the wood that fight off fungus and insects in some respect, that has been baked out of the wood. It's been, also chemically modified at that point. So that natural kind of immunity, if you will, to that is now gone. However, this is somewhat ameliorated by the fact that water-resistant nature, that baked nature, is preventing the water from the moisture from getting in the wood in the first place, which is kind of necessary for a lot of that fungus and things to actually continue to grow. So, we can't deny the fact that it is more susceptible to fungus, but the water resistance thing kind of offsets that a little bit. So in short, a harder product, a little bit more brittle, very, very, very stable. And you're going to have some color, some color change on that product as well. One of the brands that comes to mind here is Thermery. They're kind of the 10,000-pound gorilla in that particular space. And if you were to go to Thermery's website, you actually see how they use their process. And the real beauty of this is it's just heat and steam. There's no chemicals. So it's all environmentally friendly. It's pretty straightforward. Well, except the 11 herbs and spices that go into the temperature, how long the temperature, how it's controlled, how much steam, when the steam is injected, etc. That's obviously a trade secret, but it's a pretty cool product. I've had some exposure to this. I have a lot of customers who've used this not only for exterior siding, but also used it in joinery purposes for like windows and doors. And it's a huge decking product, big decking product. Now, that's thermal modification. There's also chemical modification, and a lot of people are going to be familiar with this through pressure-treated lumber, where you've taken a chemical cocktail and pushed it into the wood under high pressure, and that is essentially augmenting the natural extractives, or in some places creating natural extractives. You've got a wood that's particularly susceptible to rot. It may not have any of those natural resins that keep the water out, the natural oils that keep the water out, but also keep the bugs away. The pressure-treated cocktail, if you will, that's changed over the years and was heavily arsenic-based at one point and has been toned back to be more environmentally friendly. It's still a chemical cocktail that is increasing the rot resistance of the wood. But that's really all it's doing. You're not really getting any other changes to the hardness or anything like that. But then you've got other products. Accoya comes to mind. They're using chemical modification, and this is kind of an ammonia-based. You pick up a piece of Accoya, and it's got kind of a vinegary smell to the whole thing. And here again, the exact cocktail and exact process is all, a trade secret here. But they're using the chemical modification to actually change the cell structure. And by doing so, they're changing the properties of the wood itself. So while pressure treated is going to be rot resistant, something like Accoya is rot resistant, but it also barely moves. The change in that cell structure and the way it repels water, preventing moisture from getting into it, but also I don't want to necessarily say a hardening of the cell wall, but we'll just call it what it is. Changing of the cell structure has made an incredibly stable product that doesn't move much at all. Like, tenths of a percent of movement instead of 6% movement or 7% movement like you find in a lot of pines and domestics. And I should say, again, a lot of the chemical modification, it's mostly starting with a softwood. Pressure treated lumber is southern yellow pine. Accoya is a radiata pine. And they do that because they need a lower density wood that has a little bit more dead space, a little bit more air in it to get their chemical cocktail into it. So the real chemical modification, kind of the new frontier of chemical modification beyond the pressure treated world, involves the chemical cocktail. It involves pressure. It involves creating a vacuum and flushing that wood with that chemical cocktail, but then also curing via heating. So there is kiln drying, there's thermal modification combined with chemical modification, and that chemical reaction that occurs under the heat and the pressure is what is the resulting cell structure change of a product like Accoya. So moving on from chemical, there's biological modification. In a lot of ways, you'll find this is very similar to chemical, but you're using a naturally occurring biologic solution, usually an alcohol-based solution. So what we're really talking about is fermentation, folks. Again, I'm not a chemist, but you're talking about an alcohol solution and a biological modification. That's what I call making beer, making wine, fermentation. So the biggest product that comes to mind here is Kebony. They use an alcohol-based infusion. And here again, you're looking to, flush the wood with this. So sucking out the air and then replacing the air with that alcohol infusion. That then alters the cell structure during the heating and drying, like chemical modification. You end up with a much harder product, much harder product, and almost zero movement. So again, very similar to chemical modification, but it's a lot more environmentally friendly, if you will. It's a naturally occurring solution and resulting in a similar type product. So that's biological modification. And then finally, you have physical modification. This is where you're taking a resin and you're injecting it into the wood. In like home hobby woodworkers may have heard of a product called cactus juice, very common in wood turners, where it's got to be a smaller piece because you've got to actually fit that piece inside a vessel, pump out the air, and then the cactus juice rushes in to replace that vacuum, right? Nature abhors a vacuum. The cactus juice gets basically sucked in to replace the where the air was in that vacuum, and that cactus juice is a resin that will then cure and stabilize the wood, and it kind of freezes it in place. It also, if it's particularly soft or like a burl or something that it could be really delicate, that resin kind of glues it all together and makes it much more stable. And in the process, because you're talking about a smaller sample, the strength of the resin, the glue of the resin kind of freezes it in place and practically eliminates the movement. On the commercial sector, this is done as well. And the product that comes to mind here is called Lignia, Lignia. Very similar to Accoya in the fact that, you're sucking out the air and then flushing it with this resin, a polymer, essentially. Then it's heated, and the polymerization, the curing that occurs during heat and pressure, creates an entirely different product. Here again, Lignia starts with radiata pine, again, because of that low density, the ability to get 100% saturation of the resin into the wood. When it comes out, the big difference with physical modification, see, chemical modification, it's going in there and it's causing a chemical reaction, but it's not really adding any mass. It's not adding any physical density because the reaction happens and you get off-gassing essentially. Physical modification, the resin that goes in, as it polymerizes, it's adding mass and more importantly, adding hardness. So you have a product that here again is almost entirely stable, doesn't move practically at all. Again, we're measuring movement in 0.1% at this point. It is substantially harder. And here would be the difference between lignia and Accoya. Accoya, again, they both start with radiata pine, pretty soft species. Accoya, it's a little bit harder than radiata pine, but not substantially harder than radiata pine. It's still quite soft, typical with a softwood. Lignia is harder than hard maple. It's 3 times harder than the source material of radiata pine. And that's that introduction of that physical resin and the hardening of the resin inside the cell structure itself. The other thing is it's pretty much color fast. They, meaning Lignia, have done all kinds of tests where they've set the wood out for several seasons and there's practically no fading whatsoever. So you're kind of combining like plastic lumber with modified wood here. You're instead of building up a stick with wood flour and plastic, you're taking an existing stick and you're injecting it with the plastic, with the resin to create this product called Lignia. That's the physical modification. And I'll be perfectly honest, the company I work for, we've started carrying Lignia. So I've done a fair amount of research into the product, but at the same time, I've done research into the competitors like Accoya and Kebony and Thermery. And I think the physical modification is kind of the natural evolution. We started by thermally modifying and we saw, that could harden things and slow down the movement. And then we thought, well, let's throw in a chemical cocktail and do some further altering of things. And okay, that slowed down the movement and added a little bit hardening. And we have the warmer, friendlier, environmentally friendly biologic side of things. But then it's like, well, you know what? Let's get the best of everything. Let's get zero movement. Let's get color fastness. Let's get substantially increased hardness. Well, that's the physical modification. That's the resin injection that we're seeing here. So that's the rundown of the modification processes. And I know we're talking about this is modified versus engineered woods. Let's be honest. This podcast is primarily about modified woods because there's not much to talk about with engineered woods. You take termite barf, you glue it back together, and there's a sheet. It's cool. It's very cool. What I like about modified wood is we know how to work wood. We understand a board. We understand how to turn a board into something. And with modified wood, it's still the same process. You still are joining cope and stick together. You're still making mortise and tenons the way you would in a door as before. You don't really have to change any of that, but what you have is just a better product. It's like the $6 Million Man. We have the technology to make a better stick. And that's really what wood modification is all about. So as I said, I've had a bunch of questions on this and really kind of just answered all of those questions at once just by talking about the various processes of wood modification. But I did want to highlight a few. Andy is what he calls himself a professional woodworker. And he says, I'm seeing Accoya showing up a lot as a treated or modified wood. Accoya seems to be increasingly popular in the building preservation world for everything from trim to doors and window sash because of its supposed rot resistance. Having worked with it, I'm honestly not a fan. It's a bit brittle, and the stuff I've handled is filled with small checks, I assume from the drying process. To me, it seems suited to decking and not much else. On top of that, it's pretty expensive. I realize this is a broad question, but how durable is Accoya? Is it marketing/hype? Is that why it's now seen a rise in popularity? So it's funny that you say it seems better for decking, Andy, because I would never use Accoya for decking. It's far too soft. Let's face it, decking is like the worst thing you can do to wood. Like, why do we hate our wood so much by making it decking? It's, you walk on it, you roll stuff across it, the dogs run their, nails across it. It's heated by the sun, but only on one face only while being kept in shade on the other side. It's rained on, it's snowed on. It's just like the worst possible environment for wood. So if you have a decking product, it's gotta be hard. It's gotta be durable. And I'm gonna come back to that word durable in a minute because it means something different than I think what Andy is saying here. Accoya is just too soft. You could use Accoya for exterior siding. Certainly you could use Accoya for exterior construction, like vertical type piece, posts, and as I said, siding. But as a decking material, I know it's certainly been used as a decking material, but I just think it's way too soft. It's going to really get beat up over time. The reason it's popular in building preservation is its stability. Certainly its rot resistance is important, but its stability. When you're talking about historic preservation, you're talking about painted exteriors. I mean, it's all painted. I mean, the ultimate in water resistance is a coat of paint, right? Accoya is not pretty. I mean, it's radiata pine that's been, doused in vinegar. It's kind of got a bit of a greenish hue to it, washed out radiata pine. It's not the pretty stuff. It's definitely a paint grade wood. And because it is stable, because you can build window sash out of it and not worry about expansion and contraction seasonally, it's going to freeze it in place. And because it's got that additional advantage of being rot resistant, it's great for historic preservation. Not even just historic preservation, for exterior construction in general, but paint grade exterior construction. Yes, it is a bit brittle. And that is that chemical modification process. The slight hardening of the cell walls that causes it to be stable also makes it a little bit more brittle. My understanding, and again, all of this is trade secret type stuff, but the additional kiln drying that happens after the chemical treatment is what's causing a lot of those checks to happen, because you've hardened the walls and then you further dried it, causing a little bit more shrinkage, and those hardened walls don't really stretch anymore and they start to check. You also will find that any hardened wood like that, or hard wood like a tropical wood, is going to develop micro checks as it acclimates. So some of those micro checks you may see might actually disappear. If you just unwrapped a package come from a distributor, you're liable to see some of that checking happening. Or if you just milled it or resawed it or planed it, you're liable to see some of those checks open. Every possibility they may close up again, as well as the wood kind of acclimates. But yeah, you're going to see that little bit of checking because it is brittle. It's certainly more brittle than radiata pine. The reason I think it's so popular is Accoya was really the first kid in the game, the first person to come up with a product that was chemically modified, that had that rot resistance and that stability, and there really wasn't very much competition. It's hugely popular in Europe. It's starting to gain a foothold here in North America. North American markets are super resistant to change, so it'll take a little bit more time. But you're right, it's expensive. But think about it. Radiata pine is the source material, which is grown in New Zealand. It's then shipped over to Denmark, to Northern Europe, where it is chemically modified. And a lot of labor and a lot of work goes into it at that point to increase its cost. Then it's packaged up and it's shipped to North America. So yeah, it's traversed the globe and had all kinds of poking and prodding along the way. It is expensive stuff. So, it's fair to say, honestly, I think if you're looking for modified wood, as I said before, you might want to look at physically modified products. Again, I happen to sell lignia, so that's one that comes to mind, but there are more. There are other physically modified products out there. If you look up resin impregnation, resin infused modified wood, you'll find some different options there as well. So thanks for the question, Andy. Jeff wrote in to talk about pentacryl or pentacryl. Pentacryl. Maybe I'm putting the emphasis on the wrong syllable there. Pentacryl. You find this in like woodturners catalogs. It is, I'm going to assume, an acrylic-based solution just based on its name. I could be wrong, but for the sake of argument, I'm going to call it acrylic. Jeff is saying, can you comment on the use of green wood stabilizers such as pentacryl, particularly on larger pieces like slabs? Besides cost and effort, are there disadvantages to using this type of product? I assume I'm having a white oak with some sentimental value milled into slabs, and one of the sawyers I talked to suggested using this to reduce cracking and twisting. Thanks a lot. All right, Jeff, no, don't do that. I don't think that's a good idea. Let's talk about pentacryl. It is, again, it is a physical modification. You're taking a resin, you're taking a polymer, and you are infusing it into the wood. And pentacryl is painted on. Sometimes it's actually dipped. Here again, you find it in wood turners catalogs where you're talking about smaller pieces. You open the can and you dip your pin blank in it. It's a lower viscosity solution that when painted onto the wood, it's going to soak into kind of soft, rotten, punky, spalted areas, or soak into dead spaces around knots or burls, and it's going to harden and it's going to stabilize that wood. That acrylic is going to harden. And that's great for small pieces that, maybe are already like really delicate and punky to begin with. Those small pieces aren't going to have very much natural wood movement, or it's a burl and the wood movement's almost irrelevant because it's moving in all different directions. When you're talking about a slab, you're talking about massive amounts of wood movement. And if you start injecting a material that's going to harden and not move at all, that could be a real problem. A slab is going to have the wood movement strength to overpower that acrylic solution. I suppose unless you dip the entire slab in the solution, and then you're just talking about something that's not cost effective. Not a good idea. You've got to get a trough that you could put your slab in, that you can dunk the Pentacryl in. And the biggest issue, and I said this about physical modification, the biggest issue you're seeing here is you can't guarantee 100% homogeneous absorption of the Pentacryl. When I talked about my conversations with the Ligneo folks and how failures in the early days were because they didn't get that saturation level. They didn't get it homogenized. Well, now, so you paint it on the surface and it soaks in a whole lot around that knot. But white oak is dense. And if you remember from the exterior wood episode, white oak pores are stuffed full of tylose, making it water resistant. So there's not a lot of dead space for that Pentacryl to soak into. So it'll soak into maybe the area around the knot, or maybe a crotch figure that's got a lot more ingrain, so it can soak into the ingrain a little bit more. But 1 inch to the left or 1 inch to the right, you would have straight grain where it's not going to soak in much at all. So you're going to get very little hardening of those fibers and a lot of hardening in the fibers right next to it. That to me is a wood movement nightmare. And that could actually cause more cracking and twisting. Because the harder the material is, the more brittle it's going to become, the more that it's just going to want to crack instead of, deform and bend as the wood moves. I don't think that's a good idea at all. I think the best idea is to seal the ends using, an anchor seal type product, wax product, or a latex product. Seal those ends, stack it on something level, sticker it for plenty of airflow, and weight it if necessary. Use ratchet straps to kind of restrain the movement and just let it slowly come into equilibrium. Trying to force it to stay flat or force it to keep from cracking apart is probably going to cause more harm than good. So that, and the fact that, just the fact that buying Pentacryl, the number one place I would think to go is like a wood turner supply house, which tells me it's really meant for smaller wood samples. Finally, I have a question from Joshua on torrefaction. He says, in Lee Valley's description of the Veritas butt chisels, they write, quote, "The hard maple handle has been torrefied, a heating process that changes the structure of the wood at the cellular level, stabilizing it against swelling and shrinkage caused by humidity changes," end quote. Joshua goes on to say, what is torrefaction? Well, Joshua, congratulations. I think we've covered that. Is the end result similar to case hardening, but with the cells even more hardened? Also, I do often hear you say that even case hardened wood will still move. It will just take longer for those cells to move as much as non-case hardened timber. So is Veritas's claim about stabilizing through torrefaction similar to the stability, quote, stability of case hardened wood, where it will still take on and release water, but take longer to do it? And finally, when might you use torrefied wood in wood projects, and what would it be like to work, both machine and hand tool wise? Thanks so much. Hugely appreciate your podcast and all the time and energy invested in the show. Well, thank you, Joshua. No. Bad, Joshua. We're going to start there. I understand what you're saying about case hardening, but let's not ever refer to case hardened as stable. That makes it sound good. Case hardened wood is firewood. Case hardened wood is bad. There's more going on than, certainly as the wood is hardened in the kiln, there is, a slowing down of moisture release or moisture absorption that has caused that. But there's also been a a delamination almost of the cell structure. As you've started to see cell collapse and breaking apart of those fibers that causes that case hardened kind of honeycomb center, that's just bad. Case hardened wood, when you cut it, is going to react unpredictably. It's got so much tension going on in there, and it's quite brittle because of that hardness. There ain't nothing stable about case hardened wood, which is why I say case hardened wood is also known as firewood. So yeah, I see what you're saying, but let's just walk away from that right now and go to Veritas's claim about stabilization through torrefaction. Absolutely. As we talked about with torrefaction, it is super stable. You have chemically altered that, not chemically, you've actually altered the structure molecularly to create like that crystalline lattice. It is super, super stable. Also, the heat treating, like Shishugibon, has created that water resistant nature to the wood. So if no moisture is allowed into the wood, there will be no swelling of the wood fibers to cause expansion and contraction. So yeah, their claim about it being stabilized through torrefaction is spot on. And any torrefied wood product manufacturer like Thermaray, as I mentioned before, is going to say the same thing because it's true. That's what torrefied is doing. Baked and roasted wood is perfectly stable and insanely water resistant. So as far as how it works, well, that's the beauty of it. It works like wood. It works like a hardwood. So if you've had experience working with walnut, you're like, oh, this is great. That ain't it. It's a heck of a lot harder. You've had experience working with hard maple. It's similar. If you had experience working with something like Padauk or Granadillo or Lignum Vitae, that's a lot more similar. This stuff is hard. You're going to see some varying numbers on Janka hardness scales, so I'm not going to try to throw out numbers there because I don't have them memorized, to be honest, but they're very, very hard. But also that hardening that happens through the thermal modification does create a more brittle cell structure. And brittle is kind of a bad word. I mean, the harder the wood, the more it's going to tend to crack, right? I mean, you try to hammer together dovetails that don't quite fit in poplar, and the wood will compress and it will go together. Hammer together dovetails in Padauk that don't quite fit, and the Padauk is going to snap right away. It's going to split right down the middle because the wood is a little bit more brittle because it's harder. That's what you're going to experience working with torrefied wood, but it's not like terrible. You're going to find that it works like a really hard wood. So works great with machines, works terrible with hand tools. As a hand tool user, you're not going to find me using a lot of roasted wood in my shop because it sucks to chop a mortise in roasted wood. Hand planing is awful. The shear strength of this stuff goes through the roof. It's just not fun. So it's something you would rather sand than hand plane and use a drill or a router rather than a chisel to chop out a mortise. So there you go, Joshua. Good question, and I appreciate you asking it. And that, as I said, I got a bunch of these questions, but I kind of answered them all just by walking through the wood modification process. So that kind of brings us to the end of the show. I do want to thank everybody for the questions on wood modification, and I definitely welcome more questions and welcome feedback. We have some really cool listeners in various industries. There may be somebody listening right now who happens to work for a company that modifies wood or an engineered wood company. I'd love to hear your take on this. Correct me where I went wrong, because I'm sure that I got some technical details wrong. But from the high level, I think we've got a better understanding of modified wood and, for that matter, engineered wood. So that's it for me, folks. Go buy some fancy new modified and engineered wood and give it a shot and see what you think. And if you do, and you have some personal experience with it, let me know. I'd love to hear your feedback on the show. Thanks a lot, everybody. Talk to you next time.